Hello, everybody, and welcome back to another Mr. Farney Earth Science video. In the last weather video, we spoke about weather basics and the drivers behind the large air mass development, different types of frontal boundaries that can occur, and a little bit about the Coriolis effect and how that kind of all gives us the background setup for, the creation of weather where we live. In this video, we're going to focus a little bit more in on how we can begin gathering data for weather, what that kind of looks like in a very basic sense, and then kind of a little discussion on why it is important. So the main idea of this little section is to understand that accurate measurements of atmospheric properties are very critical for weather analysis, excuse me, and correct prediction of what's going on. So why is it important that we know? Well, the importance of accurate weather forecasting is so you can appropriately plan activities, like if you're, want to go outside or go on a trip, you want to make sure your weather is nice or your weather is ideal for whatever type of activity you're planning. Secondly, you want to make sure you're wearing the appropriate clothing. You don't want a weather forecaster to say it's going to be 75 degrees outside. You dress for 75, you walk outside and it's 20 degrees and snowing. That would just be absurd, would not work well. Thirdly, and it begins to kind of get into the more important aspect of this, you get the idea of when major storms are going to happen, maybe some large scale hurricanes or blizzards, natural disaster level type things. And then how is this going to impact your travel plans? It might not be safe to fly in an airplane or take a train, depending what type of weather is going to be over certain areas that you may be traveling through. So it's really important to know that you have the correct data to make these plans accordingly. And what meteorologists do is that they use different types of weather systems to begin gathering all the information they have so they can make an accurate prediction. Each of these has some strengths and weaknesses to them. For instance, the first one is what's called the weather radar. Strength is it can tell you exactly where rain and snow is happening in real time. The issue is that it only measures it in real time. So it only tells you what's going on right now, doesn't show you what was happening in the past, doesn't really show you what could be happening in the future. Doppler radar, that's one that a lot of weather outlets will use, and you might hear them say, and now for your Doppler radar, and then it shows the map. This shows you the speed that rain is moving either toward the radar system or away from the radar system. So it's very good at showing, wind speeds, wind direction, all that stuff. Issue is that it's very expensive to put that into place. The last one, infrared imagery, that we're going to talk about, its strength is that it measures the temperature of clouds at high altitudes. So, it can show us cold temperatures, it can show us kind of where the warm temperatures are, and then we can use that temperature indicator to know how severe of a storm we're dealing with here. The issue with infrared is that it can only really be imaged at nighttime to get a really good idea of what's going on, because daytime there's too much heating going on the Earth's surface from the sun that it could really start to askew some of these weather maps. So here's what the weather radar looks like. Again, this shows you what the precipitation is doing in real time. Over here on the left-hand side, it's color-coded and it says DBZ. That's just like the unit of measurement that they use for how intense it's raining in certain locations. So here are your indicators. The pinker the color, the more intense the rain, or the redder the color, if you will, the more intense the precipitation is at any of the locations. The bluer the colors, the lesser precipitation that's going on in those locations. So you can see right now where Nebraska is, they're getting hammered by some really heavy precipitation. Same thing up here in like Wisconsin, they're getting some pretty good precipitations out that way too. And I know that because of the redder colors that are on the map. Here are where the Doppler radar locations are, and you can see while there are a lot, they're spread out across like the United States and Hawaii and Alaska and Mexico. You'll notice that they're over land. There aren't really many Doppler radar stations that are either near the coast or in the ocean. Thank you, Bahamas, for having the one Doppler station over there in the Atlantic. So Doppler radar stations are only really useful and helpful kind of, on mainland North America here. Here's what the Doppler radar shows. Again, it shows the rain direction as it moves away from the radar system. So it's important that we have multiple of these radars, quote unquote, covering the entire country so we can accurately measure how the storm is kind of tracking across the United States as it moves to Doppler radars and away from Doppler radars. This is what it shows. This is the one that most people are familiar with when you like watch the Weather Channel or see the news. They have Doppler radar kind of set up so we can see what's going on. Here's that infrared imagery. This is of Hurricane Hugo. It was a very strong hurricane, and I know that just based on like the eye development of the hurricane there. We'll do severe weather discussions near the end of this unit. But just know the warmer reds, that's much more warm air. And I know that if the air is warm, it's rising up, it's pulling up a lot of moisture from the ocean in that area, meaning that it's going to be a very heavy precipitation oriented storm. And it's very strong right now because it still has all that red color within it. As this were to move inland, the temperature would drop. These would kind of slowly start breaking apart, be less organized. But again, we'll get more into that with our severe weather unit. So with these different tools that we have, there are different methods used to develop short-term and long-term weather forecasts. The first one is analyzing basic surface weather charts. This chart takes so many different things into account that it almost looks overwhelming. You have high pressures, you have low pressures located on the map, you have front lines drawn on the map, you have these different lines of pressure, these isobars that are connecting similar lines of pressure. You have these little, what are referred to as station models, these little black dots with kind of that almost look like arrows, all these numbers scattered across the map. Once we get through this section, you should be able to look at this map and find a location and have a pretty good idea of what's going on there. Weather-wise, is it going to be nice weather? Is it going to be bad weather? Is it raining? Might it rain in the future, depending what's going on with this map, and then go from there. So what we do is we're going to kind of break down this map into different components. We'll look at maps that show us high and low pressure. You'll do some plotting. You'll look at the station models. That way, when you come and look at this map in the future, it's not as overwhelming. You have a much better idea of how to break it down. So one of the things that we're going to do is we're going to spend some time recording weather for specific cities using station models. And this is what a station model looks like. Think of this like meteorologist shorthand for different types of weather that are occurring in an area. It shows all of these different aspects of weather that are going on in real time, your wind, temperature, what the actual weather is going on there. And we have a whole symbol chart to go along with this. Dew point, what the cloud cover is, what the pressure is, if it's increasing, decreasing in millibars, what the current sea level pressure is. All of these things are kind of shorthand and give us enough information about what's happening real time in any location around the country. We're going to have some practice building a station model. This is just, an example problem that you can come back to and try to do on your own time, but we're going to practice a lot of this during our class period. So don't worry about this too much right now. What is the difference between digital forecasting and analog forecasting? Well, digital forecasting uses over like 1,000 different variables in equation to predict the weather. It relies only on numerical data. The issue with digital forecasting is that it can take a long time to do those calculations. Analog forecasting is what meteorologists do primarily most of the time, where they look at weather patterns, they connect past patterns to current weather to try to see what's going to happen in the future. Now, meteorologists will use digital forecasting, but instead of using over 1,000 variable equations that can take hours at a time to figure out, they might reduce that, take a couple variables into account, look at what the radar maps are using, what the station models are saying, and they kind of do a hybrid of both digital and analog to get a good idea and present that information to the public so they can make a very accurate forecast based on the information that they have. The issue with forecasting long-term is that our forecasts always begin with observations. You collect data, you put it into big supercomputers that give us mathematical, models for what the atmosphere is going to do in the future. The issue is the further out you go, the less accurate it becomes because of how many variables are in play. 24-hour forecasts generally are no more than 70% accurate, and then it drops off very quickly after that. 48 hours is a 50-50 shot. 72 hours or 3 days are about 40. And then after 3 days, it's nearly impossible to get a very accurate prediction for what the weather is going to be. I will say from my own past experience, temperature is generally easier to forecast going out than precipitation, just because temperature relies on fewer variables than precipitation. So if you're looking at a long-term forecast, like 7 days out, if you look at the temperature for forecast 7 days, that is likely much, much, much more accurate than what the forecasted precipitation type is going to be 7 days out, just because there are fewer variables that go into play for forecasting temperature, which is one variable, compared to precipitation, which relies heavily on like dew point and pressure and wind speed and temperature included, and all these other factors going into it. So for long-term forecast, temperature is pretty solid, precipitation, not so much. That's where I'm going to end this video. And the next one, we're going to start talking about, the nature of storms, a little bit more into kind of severe weather, maybe a little discussion on thunderstorms, maybe get a little bit into tornadoes and hurricanes, but that's going to be in the next section of the video here. So again, if you have any questions for me, please go ahead, let me know, ask. If not, have a good rest of your day, and we'll check you out in the next video. Bye-bye.